All right, today we're going to be working on a smart 60-inch jumbo 7th generation crane. I picked this up over the weekend from a family that was moving out of state, and they had to get rid of it. It's supposed to be broken. I haven't worked on it yet. From what they told me, the motor that makes it go left and right isn't working. Somebody told them it was a bad motor, so we're going to go through and troubleshoot and figure out what the problem is. Then we'll also go through and kind of show you how to set up these cranes and some tips on how to work on these smart cranes, and how the claw strength is adjusted. So stay tuned, and we'll plug this thing in and see what it's doing. All right, I got this all plugged in, ready to turn it on here. Let's see, there's an interlock switch inside the door. I've got that on, but I have the power switch turned off. So we'll flip this on. Smart, for all of its cranes, it wants to see home position when the machine powers up. So it's got its set of micro switches. It wants to see the claw all the way forward and this carriage all the way back to home position, and the claw up. Other crane manufacturers, they go through a sequencing, a test mode that'll bring the claw out to the middle, it'll drop down and go up and come back to home to kind of figure out where its position is. So I'm going to power this up, or coin it up, and we'll see what it's doing here. It's set for $1. Oh, okay. All right. So now that should have come out to the middle, which it's not at all. I hear the music going when I go to the right, but the motor's not moving. Go back and forth. The claw will drop. So it looks like everything's working except for that left-right. Let's go through the diagnostics LEDs and see what it's doing. Just wanted to point out real quickly, this the marquee on this is Canadian Toys Vending, Plush Mania. It's a nice marquee, but it is, move the camera over a little bit, it is smart. And then on the inside here, it's got a tag here from Quebec. I assume that's all in French. I assume that's a licensing tag. So this must have been operated in Canada, sold to a distributor there, and then eventually sold to the States here. Okay, let's see, let's get centered on the logic board here. So, let me move my golden tee out of the way. Okay, that's all the way open there. The smart 7th generation logic board, this thing will pull out. Nice if that, oh, it does open more. Okay. Give me a little more room here. As you can see, this machine is massive. Okay. There we go. So we've got various diagnostics LEDs on this, and what we're going to be looking at are these little red guys right over here. Well, they're red and green. They're little telltale lights that tell you whether the motor is moving one way or the other. So the left and right, I believe, is this set here. So let's credit this up here. Let's see if all of our diagnostics are working. Okay, see the green there is telling me it's trying to go one way. Okay. This is back and forth. This is right and left. And then the claw up and down, that's down. It'll turn red when it comes up. Okay, then that's the claw close. And then here green tells me it's trying to go back to the left, which it's already at the left. So the board diagnostics are working right. And then we've got our driver ICs there. The next step, we're going to go up to the unit here. We're going to do a voltage test, and then we're going to see if we're getting our voltage. Should be about 32 volts DC, flip-flopping the polarity, coming to this motor right here. So on this assembly, you cannot take this down because there is a piece of plexi that's velcroed that keeps that whole carriage from flopping around like that. So with that out, we can drop this whole thing. I'm going to go ahead and turn the power off. Flip this over, and then I'm going to unplug my connector. So we don't damage this little snaky thing here. That harness carries everything, motor voltages and the switch returns for the whole trolley and carriage here. So now we're going to remove this cover plate here, and then there's a connector that goes on the back of the 32 volt motor. We're going to do our voltage reading there. So let me grab a screwdriver. Got my trusty fluke meter here so we can do our voltage reading. The dogs have been loving me having this window open here. They want to get in and pull out all the stuffed animals, but I've been keeping them blocked off. Okay, there's that. This cover will come right off. And then right in here, you can see we've got this connector for our motor. I'm just going to pop that off there. I'm going to plug this back in here, and then we're going to check right there for our voltage on power up. Let's see. I want to set my trolley here where it doesn't want to run, so this is all the way forward so that switch is closed. It'll think it's in its home position. Let's see. Let me get this where you guys can see it. What? Now, do I have a light here? I don't know if you can actually see that. That light. I need more lighting here. I'm going to reset my light back here. Hold on a second. Okay, I got this set up here where you can see this better now. All right, so let me get my meter ready. Now, what we have so far, my telltale lights are working fine on the motherboard, which could tell me, you know, I could possibly have a bad motor, because that's good, the motor's not turning. If the motor's bad, I should be getting a voltage right here. So let me flip this on. And I'm getting no voltage. I'm getting nothing there at all. Okay. Let me just test it and yeah, no voltage. Nothing at all. All right, so I'm going to go up here. There's another connector that it goes through before it gets to these connectors here. This is a yellow and green wire, and we're gonna, oh, let me shut this off here. Yellow and green. Just gonna stab these into the connector here. And then I need to reach way over there and get the switch. Let's see if those will stay. Okay, that's good. We'll try that. Oh, 30 volts. So, I've got 30 volts back at this connector, and I'm missing it here. So I must have a break in this wiring harness somewhere. Let's take a look at that. All right, so I've got this pulled apart. I'm going to do a continuity test on this whole harness here, starting from the corner back there. I'm checking the green wire first. I'm good. I've got continuity on the green. Let's try our yellow here. I got nothing on the yellow there. So that's telling me that yellow may not be any good. Let's see. And nothing on yellow on this side of the connector here. So my fault might be somewhere in this harness here. Let me show you one more thing here. The way this runs here, you can see this has gotten kind of messy and tangled here, and this yellow wire is exposed. I wonder if that got snagged and kind of pulled, or it broke the wire inside and left the insulation. I'm going to try to poke into that wire with my probe and see if I get continuity in the middle there somewhere. Let me tilt the camera up a little bit. Okay. Yeah, this doesn't have a very pointy tip on it. This one's better. So yeah, these probes, sometimes you can get them with a good pointy tip where you can just, you know, push it right into the wire insulation and see if you have a broken wire. So I'm going to go up in the middle here somewhere. Poke this. This one is pointy, but it's not pointy enough. Yeah, okay, I got through insulation, so my wire's good there. I'll try further back here. That's good there. Let me check this one more time. That's not good there. So somewhere up inside this thing, yeah, that's not good there. Somewhere up inside this thing we've got a broken wire. I'm going to go ahead and run a new yellow wire here and you know, clip it and splice it on both ends. So, all right, let me get some wire. All right, so I'm all set up with everything here. I've got my soldering iron, solder, heat shrinks, tubing. I was lucky enough to find a nice length of yellow wire. This is actually a very common problem on these cranes with these long harnesses. Even though it's stranded wire, it's flexing back and forth. That's eventually going to weaken the wire. Oh, let me get my strippers. All right, so I'm gonna do this here. I'm gonna cut down here and try to use that to fish my new wire through. This is gonna be, not too bad. Okay. All right. So. Oh gosh, is my brake right there? Yeah, I think I might have found my brake. It was right there. I may not need to replace this line. Let's strip that. I can probably reconnect that right there. Sometimes you can't tell where those brakes are. Let's get back on my continuity test. We might have just got lucky. Yep. Okay, so I got continuity right there. I'm going to reattach that. It's really short up to the connector. Let's see. There could still be other brakes up there. We'll fix this one. I've worked on some of these where these harnesses have been so badly hacked up, I've had to pull the whole thing out, get this sheathing off, and just redo the whole thing. Yeah, when I'm working on these, I like to make it easier for the next guy to work on it, you know. Keep the color codes the same and try to do it right the first time. Okay, good. I think I can do that. Just gotta connect that. Doesn't help that I have big fat fingers working in a small area here. I don't think I have a pin extractor for that. No, I don't have one. for that size. So I could always extract the pin. That'd really be the right way to do it. Well, okay. Try this another way. I'm going to use the solder to tin both sides of that wire here. So I get the solder flowing pretty well on both sides. Now I'm just going to join them together. Just like that. Okay. I'll slip my heat shrink over. This heat shrink is a little large, but it'll do okay with this wire. I do have the motherboard turned off. I didn't show you that, but I did turn the machine off. So I'm not soldering with the motherboard live or hot. Okay, all right, that's good. Unplug my iron. Now, one more continuity test. We'll go from the connector up there to our motor connector, and I have continuity. Okay, let's plug this in and test it out. I think I'm going to go and clean this up here too, add a couple of more cable ties. Alright, so when I turn the power on, this motor here should start turning. Good. So we got verified that the motor's good, and we've got power there now. Alright, let's get everything put back together and we'll test it out. See if we can pick up some toys. Alright, so got some zip ties here. I gotta clean that track. Put the shield back on. Unplug this. So this kind of problem on these smart cranes, it's more common for these harnesses to give trouble than for the motors to go bad, just because of the way they're designed. Trouble getting this. There we go. Now the motors for this particular machine, well, I just bought a motor from Smart for a 5th generation crane. It ran me $175. Oh my gosh. Where did my screwdriver go? There's this, there's that. Oh, let me get another screwdriver. Cranes are really pretty easy to work on. The more modern ones, you know, for the last 25 years or so, they're microprocessor controlled. They're really just electromechanical robots. They've got sensors to tell it where everything is, and the rest of it's just robotic controls. Okay. All right, so we got that on there. Snug this yellow wire back up inside here so that's not hanging out exposed. Okay. Then I'm going to tie up this bundle here so it doesn't drag on anything. Man, that's a mess. Back in its holder there. Okay, one more. Clip these. These tracks that the trolley slides on, they always get gummed up with grease, dirt, and it wears the wheels out on the trolley. So I like to go and wipe them down and clean them off. This is really bad. Eventually it won't run smoothly back and forth. It'll just kind of chatter down as it goes. Oh wow, that's on there really good. I wonder. If I can soften that up with a little WD-40. Oh yeah, WD-40's taking it right off. And when I get that off, then I want to get that WD-40 off of there. So these wheels can get some traction on the rail. Okay, I'll go back and do some of my trusty Windex. Get that WD-40 residue off there. Normally on the gears, I'll put some white grease, but there's plenty of white grease on this one right now. So, this connector back on, and Hopefully everything will still all work. Let me get it back up. Okay, that's good and tight. Oh, wow. Oh, I got this on the wrong side here. I have to go up and over the other way. Redo that here. This has to go behind. There we go. But this rail's pretty dirty itself. I'm going to clean that right now. Do the WD-40 trick. Yeah, that's a lot better. Get the other side here. Okay. So, Windex on there. I'm gonna give this thing really good cleaning once I'm done. Okay, that's great. Okay. There we go. All our wheels are on the track. And we got to get our Velcroed plexi back in place. Oh, that's so smooth. Okay. Good. All right. Moment of truth. We'll turn this on and see what it does. Aha! Very good. Right back to home position. Let me back the camera up now so you can see what I'm doing. All right. So I'm going to slide my board back in place here. I'll put some credits on. Okay. Make sure it goes all the way over. So now it's hitting my limit switch on the far end here. Back and forth, real smooth. I'm running out of time. Ah! Right at the very end there. Okay, so I'm going to see if I can set the camera up to show you how the limit switches work on this. Let's see here. So this is pretty simple here. This switch is one way or the other. There's a centering thing here. There's two switches that say it's, you know, one way or the other. And then the forward back on the trolley here, so there's one in front and one in back. And when it's all the way to one side or the other, you just have to make sure those switches are being activated. You can see here somebody's put some felt here to kind of extend the range of this white stopper here. This is on a threaded rod, so you can screw those and make them longer or shorter also. And then on these you can flex the blade a little bit to make those fit. Let's look at the claw itself. Alright, so I'm going to stop this with the claw partway down so you can see the function of how the slack works on that. Okay, so I'll just shut the machine off there. There's a switch here and a switch here. This switch here tells it when it's all the way up, and then this switch here tells it when it's hit bottom, and it's got some slack there. That slack switch is what cues the computer to activate the claw and kind of reverse things and go back home. If you ever have a motor go bad on this, these switches are very important. If this all the way up switch isn't working, that motor is going to keep turning and grinding, and it's going to burn the motor out or grind the gears out. And the same thing with this slack switch. It's got to figure out where that is. So those are very important on that. As far as the claw opening and closing, that's just a DC solenoid in there. There's no polarity on it. You can run different cranes have different voltages. This particular one, that claw, it's going to close from about 10 to maximum 32 volts DC. Other cranes, I've seen them up to 65 volts. I was working on one the other day that was 50 volts, and that was max. It was too strong, so I had to rig up a circuit to drop that voltage down to about 22 volts. So I will take a closer look at the operation of those claws too. So that's basically it. Let's play another couple of games and test this thing out. All right, switch this back on. I just want to make sure that the harness is moving smoothly all the way from one side to the other. This is a really long crane, so that harness has to move a lot. A lot of times you'll see the more standard 42-inch crane. It kind of goes from here to here. Doesn't have that far to travel, or the single cranes, or it's not that big of an issue. Okay. See, right there it's not going all the way to the end. Now it did. Oh, I see why. And this I might have to get some parts to repair. This is supposed to be attached to this unit here. That's actually broken off of there. I'm going to pull this back down. Take a look at that. See what I need to get. Well, it looks like it might just snap right in. Huh. Yeah, I might actually be able to get that in there all right. It's going to take some fancy maneuvering. Actually, I need to be small enough to just crawl inside and do it, which this is big enough. I bet you I could crawl in there and reattach this. Come on. I can't really show you guys what I'm doing. Just have to take my word for it. Oh, almost got it. Come on. Oh, it did it. Okay. Whoa. That's excellent. That's excellent. Okay, I don't know. Can you see that? I'm going to move the camera a little bit closer. Show you the motion of this. This is where it's worth if you've got one of these, getting this thing replaced, because you see this here, this attaches there, and that kind of just makes that thing roll or travel real nicely back and forth. You can see the motion on that. That'll save me a lot of heartache later on with wires breaking. And actually, this being attached would have saved that yellow wire from breaking, because that doesn't allow that connector to flex or move when it gets all the way back here where there's more torque or tension on those wires. So I'm glad I caught that. Okay, now let's really play it and see what it does. Back the camera up. Okay, lower this a little bit. I've been wanting to do a crane video for some time, but it's never seemed to have the right crane or the right time to do it. There's a lot of crane videos up on YouTube, and not any with the kind of detail I'd like to see for function and operation. Okay, so we'll go all the way over to the end. Oh, that's beautiful. It went right to the stop, no problems. Just randomly go out here. This has got that function where you can drop it a little bit and kind of center it. And oh man! We'll get it next time. I need to hire some kid to come in and play this for me, because I stink on playing claw machines. Okay. Oh, that's beautiful. I love it. Drop it a little bit. This is really kind of like cheating, you know? Oh, man. Okay, I gotta try one more time. Hold on. I know I can get it this time. It's only another $1. I love it. If I can get over the body a little bit. I don't know. Oh my God. I won. And you know what? I just discovered something else is broken. My prize meter is not working. There's a set of optocouplers right here that when a prize drops through, it racks up a number on a meter in there to tell you how many prizes you've given out. So I'll take a look at that, and we'll take a look at claw strength function, do a couple of experiments with that, and see what happens. So stay tuned. All right, so are you ready? We're going to go inside the crane here. I'll show you what's going on. I'll get this disconnected here. There we go. Okay, now inside the crane. Now you got your motherboard there. And take a peek around the corner here. This is actually big enough for a small child to get into. So now, I discovered, see up on the side there, there's those holes up above that wiring harness. That's where the prize sensor is mounted. It's missing, not in this machine, so there was nothing broken. It simply didn't have the price sensor in there. You can see in the hole here. Oh gosh, somebody left Cheerios in there. There's those holes. That's what would sense the prize going down. Well, I'm not going to worry about it because it's gone, and it's not something I would normally use anyhow. All right, so I've got a little claw here in my benchtop power supply. I'm just going to kind of show you some of the ways that operators can make these things stronger or weaker. Now there's the obvious where you have bigger and smaller prizes. You have prizes that weigh more and prizes that are really light. But for instance here, if I turn my power on, I'm about 3.4 volts. I'm going to slowly ramp up this voltage. That claw will start to pull in, or not. Why am I not pulling in? Oh yeah, okay, yeah, because I have that set on easy. Yeah, so around 10 volts. It wants to start pulling in, but you can see it's real easy to open up there. I raise that up to about 15. You can see it wants to snap closed a little more quickly. I'll go up to about 20, and it's a little bit stronger there. It's a little bit quicker on the snap close to 25, and then it's getting pretty tough. We'll go up to the max on this power supply here. You can see that it just wants to close right away. Now there's a couple of other ways we can make it more difficult. If you notice, there's this little triangular piece here. The way it's set now, it allows that claw to open all the way up so you can get around a larger animal. If you've got larger plush and you rotate that to there, then it won't open that far. So it's not able to get a grab around the item. Now there's one other thing. There's these slip rings here, so we can have an adjustment on this here. If I take an Allen wrench and I raise this slip ring here, there. This allows this to kind of go up and down like that as a unit. So it doesn't have the holding power, because as you put weight here, you can see this part here, it slips upward. So those are a couple of ways, and that's max power, and it's not even half as strong as it was when the slip ring was down in place. So those are a couple of simple ways of, if you're playing a claw machine, you can look at this little triangle here. You can look at these slip rings and see how they're adjusted. They vary a little bit from claw to claw, but they're pretty much all the same. The other thing that newer cranes do is they have a two-stage voltage. You'll come in, you'll grab the prize with that strong grab voltage, and then the computer will cut it right down to about 10 volts for a holding voltage as it's carrying it back to home base. And you can see it just, with this here, there's barely any holding power at all. And I think a lot of cranes there's an adjustment for that holding power too. So how that works, as you apply a DC voltage, to this coil, you're producing an electromagnetic field. So actually I could demonstrate. I'll show you this way. This coil's getting a little warm. I've had it on a lot here. Okay, all right, so this particular one has a stopper in it. They don't all do that. But here's the coil. And this rod down the center, that's the plunger. It works exactly the way a pinball flipper coil or any pinball coil works. Let me grab, just have a little compass here. You can see I'm going to have to move the camera a little bit closer. I want you to see how that compass is kind of free floating there. Let me get this balanced. There's all sorts of magnetic influences here, so my north-south reading's off a little bit. Look at this. Trained on that compass there. There we go. That's an old Kufel-Esser compass. So I'm going to activate this coil here for about 10 volts. You can see it's starting to influence it a little bit. I'm going to turn that voltage up. We'll go up to the max. You see it wants to follow that all the way around there. Let's see here, we'll get this balanced right there. Then I'm going to cut that voltage down there. Then the needle relaxes, so you can kind of see the effect of that. There, it's back on. The needle's just aimed on that, and then it relaxes when I turn the power off. Well, thanks for joining us today. I hope you enjoyed going through a claw machine. Like I said, it's something that I've wanted to get to for a while, and it's something that seems to be kind of mysterious to people, but they're really very simple. You can build an entire claw machine out of just simple relays. If you've got a joystick, a relay, and a DC power supply, you can take an existing crane and just make it work off of relays like that. Oh, here's this is a 5th generation smart board. Now you can see it still has electromechanical relays on it, and it's got a little rheostat for adjusting the claw strength. But it's got your microprocessor and your EEPROM for determining the programming. So anyhow, that's it for now. ZapCon's coming up. We're bringing some games. I can't tell you for sure what right now, other than I'm working on a RAS stand and building a control panel for it right now. And I'll probably be bringing a Tetris. I think we're going to do a Tetris tournament. So we'll have at least 2, maybe 3 Tetris machines there to do that. Plus we'll have some other games that we're going to bring along. So that's it for now, and thanks for joining us here at this old arcade.